Let's hear from Gopakumar with so much of experience. He has done so many studies about the short circuit fire incident across the country. Let's hear from Gopakumar. Over to you, sir.
Yes, thank you very much, Mr. Dominic. Thank you very much for the introduction. And thank you very much, Santosh Varik sir, for the nice introduction. So today again, I have a big responsibility to to introduce what exactly we need to do to enhance the safety measure. So enhancing the safety measure is very, very important. Enhancing in the sense, so currently what we are doing, are they meeting the requirements of safety, or what kind of things enhance or what kind of enhancements are required for making safe buildings is the subject. So without a big introduction, let me start. My name is Gopakumar. I am the member in the IEC TC64, which is making the standard IEC 60364, which is the global standard for electrical safety in low voltage installation. Worldwide, be it America, Britain, Germany, or any of the European nations, or Asian countries, developed nations, everywhere this particular standard called as 60364 is the basis for electrical safety against protection from shock and protection from fire. In UK, the same standard is called as BS 7671. In America, this is called as NFPA 70, or some people call it as NEC of America. And we have the equivalent, the IS 732. So with this background, I start. Whatever I'm making, I used to make a lot of technical classes, because this is not the subject is actually, we have to go deep into the technicalities of the standard, then only you will be able to understand. But today I will try to cover a little bit about what we need to do to enhance the safety. A short introduction about my company. We are into several business activities with respect to electrical safety. We are doing a lot of trainings and especially on the most modern electrical safety measures. With respect to product business, we are into lightning protection and the electrical enclosures, EMI, EMC, and so on. We are a 25 years old company. This year, February, we are actually completing 25 years. We started in a humble way in Kanyakumari, which was the other name Cape Comorin. That is why the name Cape came. Now we have got two manufacturing locations, one in Chennai and one near to Kanyakumari, and we manufacture a lot of electrical products. So with this, let's look at where do we stand with respect to electrical safety. I'm just showing you some of the paper cuttings, newspaper cuttings. 5 dead in Serum Institute fire. This happened last year during a very critical time, but luckily, 5 people died, but nothing happened to the Covishield production. The second news, short circuit has caused the 80% of Mumbai fire. Some people, electrical engineers, say that this is wrong. Electricity cannot create fire, but truly speaking, most of the fire accidents are due to electrical reason. Imagine you have a hospital, you have ICU, and suddenly fire starts from some of the equipment. Or imagine you have a house which is closed, which is completely locked. From where fire starts? It is the only, the electricity is the reason. In a residence, imagine people are sleeping, nobody is working, and under that condition, if the air conditioner starts the fire, of course, electricity is the reason. So majority of the cases, electricity is the reason for fire accidents. In 2016, a Japanese delegation by Mr. Takashi Honda, he made a presentation in the National Workshop on Electrical Safety, organized by the Central Electricity Authority in Delhi. So he made this report. According to his presentation, in India, approximately 723 people, this is the maximum, 723 people out of 100 million population per year gets electrocuted. In comparison, Japan is just 12. Let's say in UK it's just 45. Whereas in our case, these are actually, these figures are really multiples, so much multiples in comparison to all the other nations. This is with respect to the electrocution, not from the fire or not from the fire due to short circuit. Now they also made a kind of a survey asking several questions to the electricity users, and then they put marks, safety scores for each of the question. And finally, the safety score which we got is 16% out of the G20 nations, probably one of the least electrical awareness, the country with the least electrical awareness. What does it mean is, most of the electrical safety points which we think that we are aware is really wrong. So I'm just trying to explain you some of the points which we need to take care while doing the electrical installation. First of all, as usual, I start with the standard, international standard, the ISO, IEC, ITU. IEC has got beautiful standards to handle most of the electrical, the accidents. But if we look at what percentage of the safety standards are implemented in India, let us say IEC had told 100 points. How many these points are implemented in India with respect to safety? I would say not even 10. This is from my practical experience during the last few years. Most of the days, even during COVID, I was visiting sites, hospitals, and places where electrical accidents are happening. And so the situation is very clear for me. When it comes to India, the first point with respect to the rule, the first point is the regulation, which is called as the Central Electricity Authority Measures Relating to Safety and Electric Supply 2010, which is actually adopted from the IE rule, or IE rule is no more valid, which basically has come from the 1937 electricity rule made by the British. Even today, a lot of electrical, the regulations are from the 1937 rule, but nothing wrong on it. All these are in a good way. But one point which all of us should understand is the regulations are mainly concentrating up to the point of commencement of supply. What do we mean by point of commencement of supply? It means the place where the responsibility of the electricity supply company is the one which is made more into the regulation. Most of the regulations are related to electricity supply company. Now, those regulations, if we try to implement it to our house, you will be in trouble. We are not supposed to follow those regulations made for the electricity supply company. Don't try to apply it inside the house, then, because we will go into wrong. Regulation 12.2 says, for the purposes, for all other purposes, we are supposed to follow the code of practices made by the Bureau of Indian Standards, or NEC. NEC means the National Electrical Code of India, not the NEC of America. So basically, within the building, we are supposed to follow the code of practices or the National Electrical Code, and outside the point up to the meter board, let me say. Easy way is up to the meter board from the transformer. That is the responsibility of the electricity supply company. Here, once when it comes practically, what we do is the first and the foremost mistake is I always laugh at this: 2 for neutral, 2 for body. Earthing, transformer, 2 body, 2 neutral. DG, 2 body, 2 neutral. This is one of the biggest mistake which we make in India. As a result, MCBs won't trip, then finally end up with trouble. Trouble in the sense fire or electrocution, because of this misinterpretation, which is common across India. Now, I'm just showing you some of the regulation. Anyway, I don't want to read the entire regulation. If we look at the regulation starting from 12, the chapter is General Safety Requirements. Here, Regulation 14, 15, 16 are related to the electrical supply company. Why I am explaining this Regulation 14, 15, 16 is, a lot of fire accidents are happening in shops and small establishments. The small shops, warehouses, and so on, mostly are LT consumers. Now, the electricity supply company is supposed to make the supply as per the Regulation 14, 15, and 16. Now, if we go through this Regulation 14, 15, 16, the regulation says earthed or earthed neutral conductor. Then again, 15, identify, you have to identify the earthed or the earthed neutral conductor. No cutout and link shall be used in the earthed or the earthed neutral conductor. So, supplier shall provide and maintain the consumer premise, the consumers use a suitable earthed terminal. So, in several places, the regulation is saying about earthed conductor, earthed terminal. What is the meaning of it? The meaning is, you have a transformer. Imagine this is for public electricity distribution. The transformer is the source. You have the distribution, and finally you have the origin of installation. That means the point of commencement of supply. You can see a PE conductor. This is the earth wire starting from the transformer neutral up to every consumer premise. We are supposed to get a wire, the fifth wire. This is called as earthed conductor. That means the network is a TNS network, regulation 14, 15, and 16. The regulation also says earthed neutral conductor. What does it mean? Is a PEN conductor. That means at the consumer premise, see, there is a, I'm moving the cursor. You have to make a link and you have to make an earthed terminal. So basically, the regulation explains about a TNS network or a TNCS network. But if we look at really what is happening or how the electricity supply company supplies the electricity, we really find out the mistakes. Now, earthing at the distribution, in case of the neutral disconnection, regulation 41.1. For three-phase consumers, more than 250 volt earth electrode by the consumer, regulation number 16. Indication of permanent nature, regulation 15. No cutout or link at the earthed or earthed neutral conductor, regulation 15. Regulation 33 says insulation resistance test. Before the electricity supply company provide the electricity to a consumer premise, they are supposed to measure the insulation resistance, and the regulation 31, sub-regulation 1 says the periodic testing every 5 years are also necessary. So basically, a consumer who is getting low voltage electricity from the electricity supply company, the electricity supply company is supposed to ensure that all these regulations are the mandatory safety requirements they are supposed to follow. But if we analyze, now for this particular purpose, here I am showing you a kind of a meter board where between the neutral and earth a link is made. Sometimes this creates a confusion. How to handle that confusion? The IS code of practice, IS 732, for example, figure number 61. This part of the IS code explains how to make the meter board for a low voltage consumer. If you are getting an earthed neutral conductor from the electricity supplier's premise, how to make the earthing at the consumer premise, how to make the earthed terminal. These are very well explained. I just put those figures in a color format. What I have done is I have prepared two documents with these figures, which will be circulated to you probably by the end of the presentation. We will put it in the chat box so that you will get it. Now, the REC standard, REC stands for Rural Electrification Corporation, REC, because most of the, one moment please. REC is a very important organization, and the REC, most of the electrification for rural areas are made based on the REC documents. I am showing you pictures from the REC document, how to make a meter board. Now, if we look at all these drawings, again, another meter board for a single phase consumer, another meter board. These are very well documented in the REC documents. Now, if we analyze all these documents, it is very clearly and very explicitly it has written that the energy supplier, that means the electricity utility company, is supposed to provide either TNS supply or TNCS supply for a low voltage consumer. So that means the supply is something like this. First figure, look at the first figure. This is called as a TNS network. What does it mean is, The energy supplier is supposed to give an earth terminal, earth wire as well. But practically, what do? They don't give this wire. They don't make this link. So earlier there was a small link. The small link, you see, it is a small piece of wire, probably 2-inch wire. This 2-inch wire, 4 square mm, 2-inch or maybe 3-4-inch wire is actually playing a major role in safety. If you remove the link, fault current will not return back to the source. As a result, your MCB will not trip. If you have this particular link, I am showing you this particular small piece of wire, this link. If you have this link, the fault current will easily return back to the source. As a result, the MCB will trip or the fuse will trip. That is what is explained in all the technical documents, all the regulations. But unfortunately, our electricity supply companies don't make this piece of wire. Probably, the cost of this wire is a few peanuts. And this missing link or this peanuts is costing so much. This is one of the major reason for fire. So the electricity supply company is completely violating the regulations 14, 15, 16. This is one of the major reasons for fire accidents in low voltage consumer premises, such as small houses, small shops, SSI units, and so on. And all of you know very well that people are dying due to these violations. A lot of people are dying, plus property damage. I know in some places, there are some streets in the country, those who are notorious for fire. Every year, at least 2 times fire happens, and people are dying, and properties are getting lost. And always it's a big headache for the fire fighting department, fire and safety department. It's a big headache. Not for the electrical engineering department or not for the electricity distribution company. It's always the headache for the fire department. So I would recommend that the fire departments, they can very well case, ideally these violations shall be treated as a criminal offense by the management of the supply company. I repeat this wording again. Ideally, these violations of the regulation, violation of the standards shall be treated as a criminal offense by the management of the supply company. Why the management of the supply company? Because these are policy matters. Most of the time, what do? They put the blame on the last lineman and they escape. This is wrong. The management of the supply company shall be put under, for this violation. If 1 or 2 cases, if somebody can take a few cases for this violation, definitely improvements are possible. Because we don't have the habit of foreseeing the problem and rectifying it. We will see only if there is a trouble. So if the management of the electricity supply company is taken some criminal offense against them, definitely our system will improve. Now coming to the industrial installation. That means the installation which is having a high voltage supply up to the point of commencement of supply, or high-rise buildings, hospitals, hotels, industries. In those buildings, the regulation 12 of the measures relating to safety and electric supply applies. So what the regulation says is you are supposed to go as per NEC of India or the code of practice. Basically, as I said, the worldwide, the wiring rules are from the IC 60364. The Americans follow it, Britishers follow it, Germans follow it, French people follow it, all over Europe they follow it, and the equivalent standard or code of practice in India is called as IS 732 and the National Electrical Code of India. So basically, every electrical installation, that means the for a HT consumer or for places where you have your own transformer, the entire electrical installation within our building is supposed to follow the NEC of India and IS 732. When this regulation came 50, 60 years back. These code of practices are also in practice for the last 50, 60 years. We can just look at some of the points from these regulations or from these code of practices just to find out whether we follow the code of practices properly. Before that, I'm just showing you a picture, a video from the hospital, from the ICU of one of the hospital. You should understand that the people, those who are working, they identified some problem. and they started running. They are disconnecting the electrical items. This video, of course, is available in the YouTube. I downloaded it from the Times of India. So you see, within few seconds, fire starts from an electrical apparatus where they have shown this red color circle. Fire starts, and within few seconds, probably 1 minute or a little bit more than 1 minute, this entire area had become dark. It is filled with smoke. Once when the area is filled with smoke, you forget the rescue operations, the rescue and things will not work. Now, if your electrical installation is conforming to the IS 732 or these code of practices, I can tell you 100% such incidents will not happen, or probably very, very minimum. Such incidents cannot happen because you have a faulty equipment. The fire started from the faulty equipment. Now, all these reports, I was just following for the hospital fire accidents, and I was just trying to follow the reports. Most of the reports says that it is due to overload, because the hospital, the number of beds are only 25, but 50 people are admitted. Every electrical apparatus is overloaded, and the fire had started because of overload. According to me, this is a wrong statement, because in our electrical system, we are using so many protective devices, not one protective device. So many protective devices. Starting from the transformer, you have the main distribution board, incoming and each outgoing has got protective device. You have the sub distribution board, incoming and each outgoing has got protective device. You have the final distribution board, incoming and outgoings. You have so many protective devices. The question is why these devices are not tripping. One of the fundamental phenomena, or one of the fundamental principle adopted in electrical fire or fire due to short circuit is, any electrical apparatus which is having a consumed power less than 15 watts is not supposed to ignite fire. Or any fault, if it is reduced to less than 15 watts within 3 seconds, the electrical installation cannot ignite fire. So with this principle, very simple to conclude that if this MCB trip within 3 seconds, the problem has gone. There is no problem. There is no fire in that particular installation. This is the basics of the electrical safety rules. Based on that, the IS 732 and the National Electrical Code is made. And if in a properly designed, erected and tested installation during overload, the protective device should trip. It cannot catch fire. So, for example, in that case, instead of 25 patients, how to handle 50 patients? Of course, then you have to make additional wiring. You have to take care of, or you have to change the wiring, or you have to put additional wires, and you have to take it. People shall not die due to such accidents, is the point. Now, across India, one of the culprit which is creating fire is the copper wire. Copper wire manufacturers always come with the word electrical safety. They use the word electrical safety as a marketing tool. They always come with the electrical safety, saying that I have FR cable, FRLS cable, low smoke cable, and so many technical things. Actually, these are related to the insulation of the wire. What is important for electrical safety is how much heat is produced in the wire. Now, so many calculations are involved here. Several calculations are applicable here. All the calculations in the standard are considering copper conductor with class 2 copper, whereas in India we always use copper conductor with class 5 copper. Class 5 copper has got 8% higher resistance. 8% higher resistance means 8% higher heat in a single phase circuit, 16% higher heat inside a conduit. The chance of getting fire from these wires are much more. So one of my requests which I always make is, please don't use copper wires with class 5 copper conductor. You must use copper wires with class 2 conductor for any wiring inside a building, be it residential, or industrial or commercial or whatever. One of the subject which is very much important is the disconnection time. Disconnection time, say for example, in case of a fault of negligible impedance, as I told you, if you are able to disconnect the faulty circuit within 3 seconds, the chance of fire is zero, almost zero. The electrical items are not supposed to ignite fire if the fault is cleared within 3 seconds. Now, if we look at the wiring standard, IS 732, for example, these are the maximum allowed disconnection time in case of a fault of negligible impedance. It is not even 0.3 seconds. It is just 0.4 seconds, 0.4 seconds. That means in case of any fault in your electrical installation, in order to provide shock protection, in order to protect, provide fire, avoid fire, the MCB is supposed to trip within this particular time. And every electrical installation, while designing, you are supposed to take care of it. For that, the subject called system earthing plays a major role. System earthing classified into TMC, TNS, TNCS, TT, and IT. These are very much explained in the Indian standards and the National Electrical Code. But here, one of the culprit which I always fight against is called as the 2 for neutral, 2 for body. There is nothing called 2 for neutral, 2 for body. It's a total mistake. It is nowhere written or included in any standard or regulation. It's a total misinterpretation. Because of this reason, we completely do our electrical installation in a wrong way. In industrial system nowadays, clean earth, power earth, lightning protection, separate earth electrodes. This is also wrong, a big mistake. In some of the modern buildings, you put a lot of earth electrodes in soil outside the building. Example, 30 earth electrodes outside the building, and you interconnect everything under the soil, something like this. This is also wrong. One of my method to find out whether the building is electrically safe or not is just walk around the building, count the number of earth electrodes. If so many earth electrodes are there, it is an indication that the building doesn't have any electrical safety measure. So more number of earth electrodes is more problem. You are actually violating the entire rules and regulation. Now, coming to the IS 3043, which is called as the Code of Practice of Earthing, the figure number 38 to 41 very clearly explains how to make earthing. So you must interconnect every exposed and extraneous conductive part to a earth bus bar, not to the earth electrode. Similarly, another subject which we need a lot of attention is the subject called fault loop impedance. Fault loop impedance means the impedance of the circuit which is deciding the disconnection time of the protective device. If we don't follow the fault loop impedance, or if we don't test it, technically speaking, the standards, the Code of Practice IS 732 and IS 3043 recommends to calculate the fault loop impedance during the design, to test it during the erection and commissioning, to periodically check it for safe disconnection. The periodicity is also there. For example, Regulation 30 Part 1 says every 5 years. Then the first job of the electrical safety officer while doing a safety audit, he must do this particular testing, and he must ensure that your MCBs are able to trip. Unfortunately, I am yet to see a building where these tests are carried out properly. Another subject, I can put to you probably 50 different subjects, safety related subjects which are not followed in India, but I don't want to make it too long. One of the subject is called as protective equipotential bonding. In order to avoid shock and spark inside a building, every metallic object of the building must be interconnected in such a way that the voltage appearing between simultaneously accessible metallic parts must be lesser than 50 volt. Luckily, this clause has been, people started including this one line, touch voltage shall be lesser than 50 volt in a lot of tenders. I have seen these specifications in some of the modern tenders. Anyway, it is a mandatory requirement. Every metallic object in your building, such as the metal pipe, the structural steel materials, the aluminum facade, and everything must be interconnected in a typical fashion. The whole story of earthing is how you are making this interconnection. Earthing has very little to do with the earth electrode in soil. The last part, inspection and testing. The IS 732 1989, 32 years back, has included inspection and testing in the standard. There are 18 points to be inspected, starting from the method of protection against electric shock, means how you are, what is your idea, how the designer has designed the electrical system to handle the shock, handle the fire, and so on. Similarly, there are 10 different subjects for testing. Resistance of conductors means if you do this particular test, all the loose contacts can be found out. As Santosh sir told, a lot of cases the fire accidents are starting from the loose connections. So if you test as per this particular recommendation, resistance of conductor, in case of loose contact, or sometimes the loose contacts are inside the conduit, you may not be able to physically see it. But if you do this particular test, you can very easily find out the loose contacts. Insulation resistance of SELV, PELV, floor and wall resistance. The test number 4 is for reducing the shock hazard in a building. Test number 6, effectiveness of automatic disconnection of supply. And there are 10 different testings which is included in the IS 732. Now, what others are doing, foreign countries. On the right side, I have put 11 tests. There are 10 tests. And there is one more test, the test called as PAD. What does it mean? Now the idea is, the concept is, by doing this inspection and these 10 tests, you are sure that your building is very safe. Your electrical wiring is very safe. Up to your socket, things are absolutely safe. But tomorrow, if somebody connect a faulty equipment, again, the faulty equipment probably can create a fire. So how to find it out is the subject called PAD, Portable Appliance Test. In Europe and America, this test is also made mandatory. Say, for example, there is an apartment. The apartment, the electrical wiring is very well done, completely done. I will say an example. One of the leading builder in Bombay, for their high-rise building, they are implementing this particular thing. So the wiring is perfect, but now the builder is also giving a service to their the apartment owners. What they do is, they will provide 2 PAT testing instruments. 2 PAT meters are put on their common facility or the electrician's facility. So when a new a newcomer or a new owner occupies the building, the electrician go there and test all his equipment with PAT tester. As a result, the builder ensures that not only the building but the connected electrical apparatuses are also safe. So these people started doing. One of the example is, I would say, this one of the building which is coming up, or a few of the buildings of Birla Estates. They were doing such safety things. So of course, if there is an awareness, people are ready to do that. But the awareness is the biggest question. And misguiding the things. I have seen in a lot of hospitals are doing thermography, thinking that by doing thermography, you achieve all electrical safety. This is actually a misguided point. Thermography can see only whether any loose contacts or overcurrent is there. It doesn't ensure any safety from electrical fault. In fact, thermography is not a recognized test in the IEC 60364 other than solar PV. For low voltage installation, of course, solar PV, yes, but other than solar PV, thermography is not a recognized test, even in the Indian standard IS 732 or NEC. So by doing thermography, don't expect that you get all safety things. Why I am showing this picture again is some of the builders, some of the high-rise buildings in Bombay, they started doing thermography because they think that by doing thermography, everything becomes normal, or everything, you can find out the loose contacts. This is what they think. Absolutely no. Most of the time, the fault is happening, the current is flowing through the earth wire, which is normally a dead wire. With the thermography, you cannot find out the heat produced in a dead wire because it's dead. So this will actually misguide you. Please don't do it. Before that, you do all the 10 tests as per the IS 732, and probably after that you do as an additional safety thing. So for finding out the loose contacts, you should do the test number 1 in the IS 732 or test number 2, fault loop impedance. If you do these two tests, you know, all the loose contacts can be found out. So I have made, you know, during this COVID time, I visited a lot of hospitals, and I was asking the engineers in the hospital, have you conducted the test fault loop impedance or MCB tripping? The answer which I got is almost 0%. Nobody knows this particular test. So the reason is people are not aware. Now, in the new upcoming National Electrical Code, we also included this particular table. This particular table explains you the periodic testing, how periodically the recommended periodic testing in case of large buildings. So this particular table, we tried to coordinate with the table 7 of National Building Code, buildings classification, category of the building, group A up to group J building. Then a little bit explanation, and the height of the building, less than 15 meters, more than 15 meters, and the periodicity, or how periodically you must do the testing, is also included. Now, actually, by doing these, the points which some of the points which I explained, a normal electrical installation is safe. Now, in a normal electrical installation in a building, we have special locations. Special location means, example, bathroom in a house. Bathroom is a wet area. People, the chance of getting shock is much more. Near swimming pool, the chance of shock is much more. Solar PV is a special item. Rooftop solar PV is a special thing. Hospitals, group 1 and group 2 medical locations are special. Electric EV charging is special. Extra low voltage is special. Exhibitions, shows, and stands. All these are considered as special installation. These special installations require additional safety measures. How to do it? For example, a medical environment, a group 1 or group 2 medical location. A group 1 or group 2 medical location, you have medical electricals and electrical equipment and medical electrical system. Medical electrical equipment and medical electrical system. What do you do for this particular area? First, you should make a risk assessment, because this particular area, for example, the operation theater, it's an oxygen enriched area. The amount of oxygen is very high. Chance of getting, even a small spark, which can become a major fire, is much more. So also a lot of chemicals are contaminated, or chemical contents are there in that particular area. A lot of different kind of risks are there in that particular area. The first point is you should make a risk assessment as per the ISO 14971. And you have to find out what kind of safety measures you may need to implement in case of any problem. It can be electrical problem or chemical problem, or some other things. So the risk assessment is mandatory. I'm telling you, these are actually followed internationally very well. And all the medical electrical equipment and medical electrical system must conform to the IEC standard 60601. Actually, there is an equivalent Indian standard, IS 13450 Part 1 2018. So every electrical item must follow this, or the electrical equipment, medical electrical equipment, or medical electrical system must satisfy this particular standard. Number 3, when you buy a medical electrical equipment or a medical electrical system, and if you install it in your operation theater, after the installation or during commissioning, during periodic test, and after any repair, you are supposed to do a test as per IEC 62353. These 3 things are actually mandatory in a medical location. But of course, there are medical, in medical location, there is an, OT panel. People call it as OT panel. OT panel in some of the hospitals, these are implemented. But don't think that this is the only recommendation. No. As I said in the previous slide, there are 3 different things. OT panel is required, plus you need to have supplementary equipotential bonding, means the measures to reduce the touch voltage maximum 25 volt is necessary, because hospital is a wet location. Also, this location require additional test in the sense there are 10 tests specified in IS 732. There is an IS standard called IS 17512 which explains this particular subject, how to make additional test in a hospital location or a medical location. So all these things are mandatory. But to tell you the truth, I have these three things: the risk assessment, a medical location where the risk assessment is made, where all the medical electrical equipment are conforming to the IS code or the IEC standard, plus tested as per this IEC standard, is really rare. It's the rarest in our country, unfortunately. So, what I wanted to conclude is, if an electrical installation can, if we can make an electrical installation protected against overload, that means the selection of the protective device and the conductors must be handled very precisely. There are a lot of rules and regulations to be followed. Not only rules and regulations, lot of technical points you are supposed to take care. Number 2, disconnection time. Number 3, system earthing. Number 4, fault loop impedance. Number 5, protective equipotential bonding. Number 6, protective conductor current. Number 7, installation category or over voltage category. Number 8, TOVs. Number 9, inspection. Number 10, testing, periodic testing, special location. If we are able to take care of all these 12 points, plus the additional points, such as in medical location, the risk assessment and all these things, we can get an electrical installation where the chance of fire from electricity can be almost nullified. The chance of fire is nullified in the sense that there is no chance of fire. In case of any problem, your MCB trips. And in case of group 2, group 1 and group 2 medical location, IT system, MCB need not have to trip. You have a medical insulation monitor. So without MCB tripping, you achieve safety. All these things are included in the rules and regulation. Now, we don't have the habit of foresee the issues and take proper actions. This is very much missing in India. One of the easiest solution I will tell to the fire department or the people those who are from the fire department. The Electricity Act 2003 empowers Central Electricity Authority to make the rules, and in case of any violation, some of the act says it's like a criminal offense. Now the regulation 12 says your electrical installation must satisfy the code of practice of BIS or National Electrical Code. If the fire department can insist test report as per IS 732 or NEC of India for initial approval and renewal, I'm not saying the electrical approval, I am saying that the fire approval. If the fire department's document contains one line, submit the test report as per I'm sorry. Yeah, submit the test report as per IS 732, and if a perfect test report can be made, all the defects can be rectified, and this is a seal of assurance that the chance of fire is almost negligible. Now, if this is not done, in case if there is a fire accident in building, the current provisions of the rules and the act are saying that this is a criminal negligence, and you can take a kind of a criminal offense by the owners of this particular building. If you take a few cases, of course people will be afraid, or you can force people to follow the most modern things. So one of the tricky way or one of the easiest way to implement or to increase the safety in our buildings are do the inspection as per the NEC Part 1, Section 17 or the IS 732. You do the testing as per this particular standard and rectify all defects. Fire department can ask for this test report in critical buildings for fire license renewal, such as, critical building. What I say is probably for the high-rise building, hospitals, and so on. If you do that, we can very much solve the problem of fire due to short circuit. By this, I would like to stop my presentation. Thank you very much.